In this module, we are going to move from thinking about artificial intelligence as a set of technical methods to thinking about artificial intelligence as a force that is already reshaping how organizations operate across industries. Up to this point, it is easy to talk about AI in the abstract, as if it were mainly a collection of models, algorithms, data pipelines, and computational tools. But in practice, AI becomes meaningful when those tools are placed inside real organizational settings where decisions must be made, services must be delivered, risk must be managed, and people must decide whether a system is useful, trustworthy, and worth adopting. That is why a module on applications across industries is so important. It helps us connect the technical vocabulary of AI with the practical environments where AI produces value, creates new challenges, and changes the way work gets done. As we begin, I want you to listen for the relationship between the technology and the context, because the same basic AI capability can look very different when it is used in healthcare, finance, transportation, manufacturing, retail, cybersecurity, or public services. A helpful way to frame this module is to remember that organizations rarely adopt AI simply because the technology is interesting. They adopt it because they are trying to solve a problem, reduce uncertainty, improve performance, automate a process, identify a pattern, or support a decision that would be difficult to manage manually. In healthcare, that might involve using data to support diagnosis, treatment planning, patient monitoring, or resource allocation. In finance, it might involve fraud detection, risk modeling, credit decisions, market analysis, or compliance monitoring. In transportation and manufacturing, AI may appear through route optimization, predictive maintenance, quality control, robotics, and supply chain coordination. The common thread is not that every industry uses the same tools in the same way, but that AI gives organizations a way to turn large amounts of data into patterns, predictions, recommendations, and actions. As we work through the module, we will also pay attention to the different types of AI applications that appear across sectors. Some applications are mainly predictive, meaning they estimate what is likely to happen next based on historical and current data. Other applications are more focused on automation, where AI helps carry out routine, repetitive, or highly structured tasks with less direct human effort. Still others function as intelligent decision support systems, where the goal is not to replace human judgment entirely, but to give decision makers better information, clearer options, and stronger analytical support. This distinction matters because the risks and responsibilities are not identical across application types. A forecasting system, an automated workflow, and a decision support tool may all be called AI, but each one changes organizational behavior in a different way. At the same time, we need to avoid treating AI adoption as automatically positive or automatically harmful. The value of AI depends on how well the system fits the problem, how reliable the data is, how carefully the organization implements the technology, and how responsibly people govern its use. AI can improve efficiency, forecasting, operational performance, customer service, fraud detection, scientific discovery, and public service delivery. But the same systems can also introduce costs, technical complexity, ethical concerns, workforce disruption, privacy risks, and reliability problems if they are poorly designed or poorly managed. A graduate level understanding of AI applications therefore requires more than knowing where AI is being used. It requires asking what the system is doing, who benefits, who may be affected, and what limits must be recognized before the system is trusted. By the end of this module, The goal is for you to see AI as both an organizational capability and a socio-technical system. That means we will examine AI not only as software, but also as something embedded in business processes, professional roles, institutional goals, regulatory pressures, and human decision making. When an organization introduces AI into a supply chain, a customer platform, a fraud detection process, or a public service, it is not just adding a tool, it is changing the flow of information, responsibility, and judgment. This is where the study of AI applications becomes especially important, because it helps us understand why the same technology can create efficiency in one setting, concern in another, and strategic advantage in a third. As we move into the specific learning objectives, keep this broader perspective in mind. AI across industries is not only about what machines can do, but about how organizations choose to use those capabilities responsibly and effectively. When we identify the major domains where artificial intelligence is deployed, we are really asking where data, computation, and organizational need come together in a meaningful way. AI does not enter every industry in the same form, and it does not solve every problem through the same method. In one setting, it may operate quietly in the background, ranking information, detecting anomalies, or forecasting demand. In another setting, it may be visible through a chatbot, a recommendation system, a medical imaging tool, a fraud alert, or an automated scheduling platform. What connects these uses is that AI systems are designed to recognize patterns at a scale and speed that would be difficult for people to manage manually. So as we look across healthcare, finance, transportation, manufacturing, retail, cybersecurity, and public services, we should treat AI less as a single product and more as a broad technological capability that adapts to the priorities of each domain. Healthcare is one of the clearest examples because the field generates enormous amounts of data and many decisions depend on timing, accuracy, and context. AI can support clinicians by helping analyze medical images, flagging possible risks in patient records, assisting with triage, or identifying patterns that may inform treatment planning. That does not mean the system replaces professional judgment, because healthcare decisions involve human expertise, patient values, ethical responsibility, and regulatory oversight. But AI can help organize complex information so that professionals are not forced to rely only on memory, manual review, or fragmented records. In this sense, the value of AI in healthcare is often connected to decision support, where the system helps make hidden patterns more visible. The same basic idea appears in public health and hospital operations, where predictive tools may help anticipate staffing needs, patient flow, or resource shortages. Finance shows another major domain of AI deployment, but the emphasis there often shifts toward risk, prediction, and trust. Banks, insurers, investment firms, and payment platforms operate in environments where small changes in behavior can signal fraud, credit risk, market movement, or compliance concerns. AI systems can examine transaction patterns, detect unusual activity, support loan assessment, and help institutions respond more quickly to emerging risks. Again, the purpose is not simply to make the organization faster, it is to help the organization make better decisions under uncertainty. Financial data can be massive, fast-moving, and highly sensitive. So AI becomes useful when it can separate meaningful signals from noise. At the same time, this domain reminds us that deployment must be handled carefully because errors in financial AI can affect access to credit, customer trust, legal compliance, and institutional reputation. Transportation, manufacturing, and retail extend the same logic into physical operations and customer-facing systems. In transportation, AI can support route optimization, traffic prediction, autonomous navigation, fleet management, and maintenance planning, all of which depend on interpreting changing conditions over time. In manufacturing, AI is often connected to automation, robotics, quality inspection, predictive maintenance, and production efficiency. The factory floor produces data through machines, sensors, inventory systems, and workflow tools. And AI can help convert that operational data into better timing, fewer failures, and more consistent output. Retail uses AI in a different way, often by focusing on demand forecasting, inventory decisions, product recommendations, pricing strategies, and customer personalization. Across these domains, AI is not only analyzing information, it is shaping how goods move, how services are delivered, and how organizations respond to customer behavior. Cybersecurity and public services show why AI deployment is also deeply connected to protection, governance, and social responsibility. In cybersecurity, AI can help identify suspicious patterns, detect intrusions, prioritize alerts, and support analysts who are facing more data than they can reasonably inspect by hand. This matters because security threats change quickly, and organizations need systems that can recognize unusual behavior before damage spreads. Public services use AI in areas such as service delivery, resource allocation, citizen support, emergency response, and administrative efficiency. These applications can improve responsiveness, but they also require special attention because public institutions have obligations related to fairness, transparency, accountability, and due process. When we identify where AI is deployed, then, we are not simply making an industry list. We are tracing how decision making, automation, and predictive analysis are becoming embedded in the systems that organize modern life. When we analyze how artificial intelligence systems create value, we need to begin with a simple but important idea. AI is valuable when it helps people and organizations turn data into better action. Data by itself is not enough. Many organizations already have large amounts of data stored in transaction systems, customer platforms, sensors, documents, and digital records. The challenge is that raw data is often too large, too messy, or too fast moving for human decision makers to interpret directly. AI becomes useful when it can detect patterns inside that data, organize those patterns into meaningful signals, and support decisions that are more timely, more informed, and more consistent. So the value does not come from the model in isolation. It comes from the way the model converts information into insight and insight into action. This is why the slide emphasizes actionable insights. An insight is not simply an interesting observation, and it is not just a chart that shows what happened in the past. An actionable insight helps someone decide what to do next. For example, an organization may use AI to identify which products are likely to be in demand, which customers may need support, which machines may fail soon, which transaction looks suspicious, or which patients may require additional attention. In each case, the system helps the organization move from passive observation to active response. That movement is central to AI value creation because organizations operate under constraints. They have limited time, staff, budgets, and attention, so they need ways to prioritize what matters most. Forecasting is one of the clearest ways AI creates organizational value because many business and public sector decisions depend on expectations about the future. A retailer wants to anticipate demand before inventory runs out. A hospital wants to estimate patient volume before staffing becomes inadequate. A bank wants to assess risk before losses occur. A city may want to predict service needs before problems become larger and more expensive. Forecasting does not remove uncertainty, and it should not be treated as a guarantee. However, good predictive systems can reduce uncertainty enough to improve planning. They allow organizations to prepare rather than merely react, which supports better resource allocation and more strategic decision making. AI also creates value through automation, especially when routine processes consume human effort without requiring deep human judgment every time. Many routine tasks are essential to organizational performance, such as processing forms, routing requests, reviewing transactions, scheduling workflows, classifying documents, or monitoring systems for common issues. When AI helps automate these processes, employees may spend more time on complex, relational, creative, or judgment-heavy work. Often, the goal is to reduce bottlenecks, improve consistency, and allow human workers to intervene where their expertise matters most. This is why successful AI adoption requires thoughtful process design, not simply adding a model to an inefficient workflow. The third major source of value is support for complex decision making. Complex decisions usually involve multiple variables, competing goals, incomplete information, and consequences that may affect many stakeholders. AI systems can help by synthesizing large amounts of information, identifying possible relationships, and presenting recommendations or risk indicators to decision makers. In an organizational context, this might support strategic planning, operational management, financial analysis, or customer service design. In a societal context, it might support public health planning, emergency response, infrastructure management, or access to public services. AI can expand the analytical capacity available to institutions, but it does not eliminate the need for human responsibility. People still need to ask whether the recommendation is appropriate, whether the data is reliable, and whether the outcome is fair and useful. This is where organizational value and societal value begin to connect. A business may adopt AI to increase efficiency, improve forecasting, reduce costs, or strengthen strategic planning. Those goals can create value for the organization, but they can also affect customers, employees, communities, and broader markets. Public institutions may use AI to improve service delivery, manage limited resources, or respond more quickly to changing needs. These uses can produce social benefits, but only when they are implemented with attention to transparency, accountability, and trust. AI creates value most effectively when it strengthens human decision making rather than obscuring it. As we move forward, keep that balance in mind. AI value is not measured only by speed or automation, but by whether the system helps organizations and societies make better, more responsible decisions. When we compare different types of AI applications, it helps to move away from the idea that AI is one single kind of tool. In organizations, AI appears in several forms, and each form changes work in a different way. Some systems are designed mainly to predict, some are designed mainly to automate, and some are designed mainly to support decisions that require human judgment. These categories often overlap, but separating them gives us a clearer way to understand what the system is doing. A predictive analytics tool, an intelligent automation tool, and a decision support system may use machine learning, data processing, and pattern recognition. But the organizational purpose is not identical. The first helps anticipate what may happen. The second helps carry out work more efficiently. And the third helps people reason through complex choices. Predictive analytics is one of the most common AI application types because organizations need to make decisions before the outcome is fully known. These systems analyze historical and current data to estimate future events, risks, trends, or behaviors. A predictive system might forecast customer demand, estimate equipment failure, identify a patient at elevated risk, or flag a financial transaction that resembles earlier fraud patterns. The practical value is that prediction gives an organization time to act. It allows leaders and professionals to prepare, allocate resources, adjust strategy, or intervene before a problem becomes more serious. Prediction, however, should be understood as probability, not certainty. A well-designed predictive model can improve judgment, but it cannot remove uncertainty from the environment. Intelligent automation is different because its primary purpose is to perform or coordinate tasking with less manual effort. Automation can involve simple rules, but intelligent automation becomes more powerful when AI is used to classify information, interpret language, recognize images, route requests, monitor workflows, or respond to routine conditions. In a business process, this might look like sorting service tickets, extracting information from documents, updating inventory systems, scheduling maintenance, or triggering alerts when a process moves outside normal limits. The value is not only speed, the deeper value is consistency, scalability, and the ability to reduce repetitive workload so that people can focus on higher level responsibilities. Still, automation must be designed carefully because mistakes can scale quickly if the system is poorly governed or connected to weak data. Decision support systems represent a third category, and they are especially important in settings where decisions are too complex to be fully automated responsibly. These systems gather, analyze, and present information in ways that help people make better choices. A decision support system may recommend options, rank priorities, identify risks, simulate outcomes, or explain patterns that are not obvious from raw data. In healthcare, finance, cybersecurity, public administration, and management, this kind of AI can be valuable because professionals often face incomplete information and significant consequences. The goal is not necessarily to replace the person making the decision. Instead, the system expands the decision maker's analytical capacity by making relevant information easier to interpret. The human decision maker remains responsible for context, ethics, professional standards, and final judgment. Comparing these application types also helps us think about benefits and risks. Predictive analytics can improve forecasting, but it can mislead users if data reflects outdated patterns, bias, or unstable conditions. Intelligent automation can improve efficiency, but it can create problems if people lose visibility into how a process works or if there is no clear way to correct errors. Decision support can strengthen analysis, but it can also create over-reliance if users treat recommendations as unquestionably correct. So the question is never simply whether AI is present. The better question is what role the AI system plays in the workflow. In practice, many real-world AI applications combine these categories. A fraud detection system may predict suspicious activity, prioritize alerts, and support analysts as they decide whether to investigate. A supply chain platform may forecast demand, automate replenishment, and help managers evaluate trade-offs involving cost, timing, and risk. These examples show why the categories are not rigid boxes. They are analytical tools that help us understand the main function of an AI system. As you study AI applications across industries, keep asking what kind of value the system is designed to produce. Is it helping the organization see patterns earlier, operate more efficiently, or make better decisions? That comparison gives us a disciplined way to understand AI adoption beyond the label itself. Evaluating the benefits and limitations of AI adoption requires us to hold two ideas together at the same time. On one side, AI can create real improvements in efficiency, operational performance, forecasting, and decision making. On the other side, Those improvements are not automatic, and they do not appear simply because an organization purchases a tool or trains a model. AI adoption changes how work is organized, how information flows, how decisions are supported, and how responsibility is distributed. That means the benefits must be evaluated alongside the conditions that make them possible. A system that works in a demonstration may still struggle when it enters an organization with legacy data, uneven processes, regulatory expectations, and people who need to understand its effect on work. The most visible benefit of AI adoption is improved efficiency. Organizations often use AI to reduce the time required for repetitive analysis, classification, monitoring, routing, scheduling, or information retrieval. When a system can process large volumes of data quickly, it can help teams move faster and reduce delays that would otherwise slow down service delivery or response. But efficiency should not be understood only as speed. A mature view of efficiency also includes consistency, scalability, and the ability to use human expertise where it is most valuable. If AI handles repetitive or data-heavy tasks, employees may have more capacity for interpretation, communication, strategy, and problem solving. That is one reason AI is attractive across industries. It can help organizations do more with limited resources as demand, complexity, and data volume increase. AI can also enhance operational performance by helping organizations detect problems earlier and coordinate activities more effectively. In manufacturing, it may identify quality issues before defective products move further through production. In transportation, it may anticipate maintenance needs before failures disrupt service. In finance, it may identify suspicious activity before losses increase. In healthcare, it may recognize patterns that deserve clinical attention. The value here is connected to responsiveness. AI can help organizations move from delayed reaction to earlier intervention, which often reduces costs, improves reliability, and strengthens the experience of customers, patients, employees, or citizens. But this kind of improvement depends on data quality and on whether the AI output is integrated into the workflow. Better forecasting and decision making are also major benefits. AI systems can identify relationships in data that may not be obvious through manual review, and they can use those relationships to support planning under uncertainty. Forecasting demand, estimating risk, predicting equipment failure, or modeling future service needs can help leaders allocate resources more intelligently. Decision making improves when the system gives people clearer information, better timing, and a stronger basis for comparison. Still, forecasting is never perfect, and AI does not remove the need for judgment. Models are built from available data, and that data may be incomplete, biased, outdated, or poorly matched to new conditions. A forecast should therefore be treated as decision support, not as a substitute for thoughtful analysis. The limitations of AI adoption are just as important because they explain why implementation can be difficult. Technical complexity is one major limitation. Organizations need data infrastructure, cybersecurity protections, integration with existing systems, model monitoring, and people who can evaluate whether the system is performing appropriately. Cost is another limitation, and it includes more than software licensing or cloud computing. It may include training, workflow redesign, specialists, data preparation, maintenance, and risk management. Ethical concerns also matter because AI systems can affect privacy, fairness, accountability, and transparency. If a system influences decisions about money, employment, healthcare, education, public benefits, or security, the organization must examine how the system reaches conclusions and who may be harmed by errors. Workforce changes and system reliability bring the evaluation back to the human side of adoption. AI can change job roles, reduce tasks, create new skill requirements, and raise anxiety about automation. Organizations that ignore these effects may face resistance, even when the technology itself is strong. Reliability is a continuing concern because AI systems can fail in subtle ways. A model may perform well on historical data, but weaken as conditions change. It may produce confident outputs that are wrong, especially when it encounters cases outside its training environment. For that reason, evaluating AI adoption means asking not only what the system can do, but how it will be governed, monitored, corrected, and explained. Artificial intelligence is transforming business processes and services by changing how organizations sense what is happening, decide what should happen next, and deliver value to the people they serve. A business process is not only a set of tasks on a flowchart, it is a pattern of work that connects data, people, systems, rules, and outcomes. When AI enters that pattern, it can change the timing of decisions, the level of personalization, and the speed of response. This is why AI transformation is deeper than simple automation. It does not merely make an old process faster. In many cases, it forces the organization to rethink the process itself. Supply chains provide a strong example because they involve constant coordination across suppliers, inventories, transportation networks, demand signals, and operational risks. AI can help organizations forecast demand, identify disruptions, optimize inventory, and adjust logistics before a shortage or delay becomes more damaging. A traditional supply chain may rely heavily on periodic reports and human reaction after a problem becomes visible. An AI-supported supply chain can use data from sales, weather, transportation, supplier performance, and market conditions to support earlier decisions. The value is not that the system controls uncertainty. The value is that it gives managers a better view of uncertainty so they can make choices with more timely information. Customer personalization is another area where AI has deeply changed service delivery. Digital platforms, retailers, banks, media services, and educational technologies all use AI to interpret user behavior and tailor experiences. Personalization may involve recommending products, adapting content, prioritizing support, adjusting offers, or identifying when a customer may be dissatisfied. When done well, personalization can make services more relevant and reduce the friction between what a person needs and what the organization provides. But personalization also reminds us that transformation must be responsible. If organizations personalize without transparency, privacy protection, or respect for user autonomy, the same capability that improves service can also create discomfort, manipulation, or unfair treatment. Fraud detection shows how AI transforms processes by shifting organizations from delayed investigation toward real-time monitoring. In financial services, insurance, retail, government programs, and cybersecurity, fraud often appears as a pattern hidden inside large volumes of normal activity. AI systems can examine transactions, claims, logins, account behavior, and other signals to identify activity that deserves closer review. This does not mean every flagged case is fraudulent, and it does not mean AI should be treated as the final judge. Instead, the system can prioritize attention, reduce the burden on human analysts, and help organizations respond before losses grow. This is an example of AI as decision support because the model improves the process by focusing human judgment where it is most needed. Operational performance is transformed when AI becomes part of how organizations measure, monitor, and improve everyday work. In manufacturing, AI may support quality control, predictive maintenance, and production planning. In logistics, It may improve routing, scheduling, and resource allocation. In service organizations, it may help manage call volume, response times, staffing patterns, and workflow bottlenecks. These improvements matter because organizations often lose performance through repeated small delays, errors, mismatches, and inefficiencies. AI can help detect those patterns and guide adjustments earlier. However, operational transformation depends on whether leaders understand the process well enough to redesign it around useful information, rather than simply adding technology on top of existing problems. Public services and scientific research show that AI transformation reaches beyond private business. In public services, AI may support citizen assistance, eligibility screening, emergency response, infrastructure planning, and allocation of limited resources. These applications can improve speed and consistency, but they also require careful governance because public systems affect rights, access, and trust. Scientific research uses AI to analyze large data sets, detect patterns in experiments, accelerate discovery, and support modeling in fields ranging from medicine to climate science. Digital platforms use AI to organize information, recommend content, moderate activity, match users with services, and manage interactions at massive scale. Across all of these settings, the transformation is not only technical, it is organizational, ethical, and strategic. AI changes business process and services most effectively when it's connected to clear goals, reliable data, human oversight, and a serious understanding of the people affected by the system.